Hello folks, in this video we'll see how to solve the largest rectangle in histogram problem, which is a hard problem on LeetCode. So we'll be given an integer array which can be represented as a histogram. So from this histogram, what we have to do is we have to find a rectangle which has the maximum area. So to find the area, we need height and width of the rectangle, right? So how we can solve this problem is we can loop through the array and anyway we know the height, it's given in the question, right? For each element we know the height. And also we need to find, like for that particular element or bar, what is the maximum width up to which it can expand. Okay, that is we have to find till what index we can expand towards left and to what index we can expand towards right. Okay, that is we need to find the left limiting index and right limiting index for each elements. That is that will be the width of the element or bar, right? So once we get the width and height, we can multiply it and we'll get the area. So before we start coding, there are two observations here. First observation is for the first and last element, we don't have the expansion towards left and right respectively, right? That is for the first element, we cannot expand towards the left further, right? That is the first element. So in that case, we can say the limiting index for the first element is that particular index minus 1. That is, we are at index 0, that is 0 minus 1, that is minus 1 will be the limiting index for the first element. Similarly, for the last element, we know that it cannot expand towards the right further, right? So for that particular element, the limiting index towards right will be the index at which that element is plus 1. So the last element will be at n minus 1 index, right? So n minus 1 plus 1. So the limiting index for the last element will be n minus 1 plus 1 equal to n, right? So that is first observation. And a second observation is when we are considering an element and we are let's say we are checking for the expansion towards left. Okay, so we know that the element which is neighbor to it, that is which is to the left to it, when we are calculating the expansion towards left, we can say if at all we would have found out the result for the neighbor, right? Since we are using since we are iterating through the elements, all the elements, so we can say if at all the neighbor is greater than or equal to the element under consideration, that is the height of the neighbor is greater than or equal to the element under consideration, that the element can be expanded, right? If it is less than the element under consideration, it cannot expand further because it requires a certain height, right? This height of the current element. So if it is greater than or equal to the element, then we can use the result of the neighbor itself, right? Because we already found out that the neighbor can expand till this particular index. So we can use that particular result plus, not plus, like I mean, once we find out till what index it can expand, from that index we can continue checking, right? So we need not have to check all the indices in between that, right? So why we are doing is because we need to use a nested for loop, right, in order to find this. So if at all we are checking all the indices, like in the worst case or average case, if it's n square, if we are doing a check of n square, then that may result in time limit exceeded error, right? So we have to save time, right? So we can do this, like if at all the neighbor's result can be used, we can use it, right? Why not waste time in checking repeatedly the already known results, right? So with this observation, let's start coding. Okay, so what we can do is initially we can have two arrays for storing the left limit, and that is limiting index for the left and right side. Okay, for all the elements. So let it be array left limit equal to array of zeros. So n is length of array, right? Len of heights, And similarly, we can have right limit. And as I said before, for the first element, we don't have a expansion towards left. So the limiting index will be -1, and for the last element, limiting index towards right will be n, right? So we can write that result in the beginning itself. So left limit of first element will be -1, and right limit of last element, right, that is n-1 will be n-1 plus 1, that will be n. Okay, so here we have the initial results. Now what we can do is we can find the left limiting index for all the remaining elements apart from the first element. Okay, so for that we can use for loop for I in range from index 1 till n-1. We can say pointer equal to I-1. Let it be at the let's say currently it's expanded to one index before that. Okay, let's check whether we can move further. Okay, so we can use a while loop. While what we can check is if the neighbor to the left is having height greater than or equal to the element under consideration, we can expand, right? If it is less than, we cannot. So we can say if heights of pointer greater than or equal to heights of I. If this is true, then what we can do is we can update the pointer to the neighbor's result, right? If the neighbor is greater than or equal to the element under consideration, we can expand it further. So the result of the neighbor can be used here. And once we have the left limiting index of the neighbor, from that we can directly go to that particular pointer, right? So from that pointer again we can continue checking. So this while loop will do that thing. Okay, so pointer will be left limit of, that is the previously calculated result of neighbor, like left limit of pointer, right? Pointer. So this will be updated accordingly, and at last the pointer, and again we need to check here, like while I grade pointer greater than or equal to 0, right? Because we don't want the pointer to go beyond 0, right? We have to check till like we need not have to, we should not allow the pointer to move out of bound, right? So we need to do that check also. And at last, after the while loop, we can update, right? Left limit of I equals pointer. So similarly, we have to do for finding the right limit also, right? So we can use for I in range. This time we'll be moving from right to left. That is, we'll be doing checking in reverse, right? Reverse order. So it will be n-2 starting from n-2th index till 0, right? So we are moving backwards. So this step will be -1. And the same way we can use the pointer as I plus 1, and we can use the while loop in a similar way. Pointer is less than n, and we can say heights of pointer is greater than or equal to heights of I, right? In that case, we can expand. So we will take the result of neighbor left of, okay, sorry, right limit, right limit of pointer. So it keeps on going pointer, and once the limiting index is found, the while loop will break. Okay, and at last we can update right limit of I equals pointer. Okay, now we have found out the limiting indices for all the elements. That is, now we know what is the width of each bar, that is to what extent each bar can expand. Okay, also we know the height. Now we can use a for loop to find the area, and from the areas we find or we can find out, right, which one is the maximum. So we can use a for loop for I in range n, or we can say height equals heights of I, right, and width will be the right limiting index minus left limiting index minus 1. That will give the exact width of the bar, right. So right limit of I minus left limit of I minus 1. Now the area is height into width, right, and we can check. We need to have a variable, right, to store the maximum area. So max area equals 0 initially, let it be 0, and here we can check max area equals max of max area or the newly calculated area. Okay, so after the for loop we'll have the result with us, so we can return the max area variable. So let's try running it. Yeah, it's working. See you in the next video.